All right, also here's some help on worksheet 6. Again, this is our sum or difference of cubes. These first few problems is just factoring. So when you look at this first one, uh, always start when we're factoring with the greatest common factor no matter what. 125 and 8y cubed, they don't have anything in common, so we can't do the greatest common factor, but you always need to start there. After that, we look at 125 and 8, and hopefully you can notice that those are perfect cubes. Right, that's what's going to tell us to do the sum or difference of cubes. Now the way we set that up is very similar to how I would set up the difference of squares. Ask yourself the question, what would we have to put in this parentheses to get 125? If we're raising it to the third power, well, that's a 5, right? 5 to the third power is 125. If you can't think of that, just do the square root or the cube root of 125. That will give us a 5. Same question here for the 8y cubed. Well, 2 to the third power gives us 8, again because the cube root of 8 is 2. Y to the third power gives us y cubed, and that's because the cube root of y cubed is just y, giving us a 5 and a 2y, which become very important in our factoring. That 5 and 2y actually give us that first factor there. What goes in between is minus, because the original problem is subtraction. To fill in that second parentheses, that's where we're going to use this fact of 5 to the third power here means 5 times 5 times 5. 2y to the third power means 2y times 2y times 2y. And what we're going to do is pair them up from left to right. Okay, so we pair them up and now we multiply, right? 5 times 5 is 25. 5 times 2y is 10y. 2y times 2y is 4y squared. Almost finishing off our problem. To get those signs that go in between 25 and 10y and 4y squared, that's when we use SOAP. Right? Again, how SOAP works is the S stands for same, right? So same as the original, minus. The O stands for opposite. So opposite from subtraction would be addition. And that last step, AP, stands for always positive, telling us that this is always going to be addition there. Which factors are trinomial, or factors that difference of cubes completely there. I'm just going to rewrite it down here. 5 minus 2y, 25 plus 10y plus 4y squared. Just make sure when you get to this point, these two signs here should be opposite because of SOAP, so just make sure you always check that just to be certain. But that hopefully helps you out there with number 3. Alright, so here's another of these just factor them completely problems. Again, we look at this 64a cubed, 125r cubed, and we start here every single time. Is there a greatest common factor? 64 and 125, you have to think about that a little bit, but they don't have a greatest common factor, so we're just going to move in to our process of factoring. Now again, what I noticed right off the bat is we have these exponents of 3, we have a 64 and 125, those are both perfect cubes, which means we're doing the sum or difference of cubes. Again, how it works is very similar to the perfect squares. Ask yourself, what to the third power gives us 64a cubed? Well, 4 gives us 64. A to the third power gives us a cubed. Again, you can get that from the cube root of 64, a cubed. For the 125, right? 5 to the third power gives us 125. R to the third power gives us r cubed. Again, you could just do the cube root of 125 r cubed there to get that 4a and that 5r, which are our critical pieces for our factors now. Right? Our first factor uses that 4a and the 5r without the cubes, and what goes between them is subtraction, because that original problem is subtraction. To fill in that second parentheses, again, this is where we're using this fact that 4a to the third power means 4a times 4a times 4a. 5r to the third power means 5r times 5r times 5r. And we pair them up. Okay, left to right. 4a times 4a is 16a squared. 4a times 5r, 4 times 5 is 20. AR, doesn't matter which order you write those in, you can put RA, doesn't matter. 5R times 5R is 25R squared, giving us that second factor right there. And to figure out what goes in between all of these numbers, that's where we use SOAP, right? Same, opposite, always positive. The original was subtraction, so that's why this stays subtraction. The opposite of subtraction is addition. Always positive means that's always addition there at the end, giving us our factored form. Again, let me just write it down here. Minus 5R, 16A squared plus 20AR plus 25R squared. Finishing off number 4 there. So make sure you're taking your time when you're finding those two key pieces of information, because that's kind of what gives us our entire factored expression. Okay, so here's the last one of these factor completely problems that I'm going to do for y'all. Again, you look at this, and anytime it asks you to factor, always start with the greatest common factor, because look what happens here. 81 and 3, what do they have in common? Well, they can both be divided evenly by a 3. Also, they both have y's, right? Y to the 4th, y. We can factor a y out. So start with the greatest common factor there of 3y. We take the 3y out. Again, if you don't remember how to figure out what's left over, we're just dividing each piece by 3y. 81 divided by 3 is 27. Y to the 4th divided by y leaves you with y to the 3rd. 3y divided by 3y, well, those cancel out completely, but that doesn't mean we just put a 0. Anything divided by itself gives us a 1, giving us that as our factored expression after the greatest common factor. But wait, we're not done, right? We need to factor this completely. So now we look at what we have left in the parentheses, right? This. Can we factor that further? And the answer is yes, we can. 27y cubed plus 1, that is a sum of perfect cubes. I'm sorry, I'm trying to find the pen right now, and it's there we go. 27y cubed plus 1 is a sum of cubes. I'm just going to take that down here and work with it. Now don't forget about that 3y, we'll tag it on at the end. This is where we look at, right, what to the 3rd power gives us 27y cubed, 3 to the 3rd power is 27, y to the 3rd power is y cubed. What to the 3rd power gives us 1. 1 is always nice, we can just put a 1 there, right? 1 to the 3rd power gives us 1. And now we can jump into the factoring, right? The first factor, we use that 3y and that 1. Since the original problem is addition, we put addition in between. To find that second parentheses there, again, we write 3y 3 times, 3y, 3y, 3y. We write 1 3 times, 1, 1, 1, and we pair them up. 3y times 3y is 9y squared. 3y times 1 is 3y. 1 times 1 is 1. To finish it off, fill in the signs. That's where we use SOAP, same, opposite, always positive. Same as the original is addition. Opposite from that is subtraction, and that's always positive at the end, which would be our factored version of 27y cubed plus 1. This is where you have to be careful. We did factor out this 3y at the beginning. It tags along the entire time and sits in front, making that our final factored form. Okay, so you just have to remember to not forget the 3y, which allowed us to use our sum of cubes there. 9y squared minus 3y plus 1. That would be our completely factored expression. Again, starting off with the GCF, that allowed us to do the sum of cubes there, which is pretty nice because now we have this factored expression. If you need any more help on this, I'm going to do a couple more where we actually have to go through and solve, or come to my office hours. All right, here we go, and we're gonna go over 9 and 10. Just because Mr. Everly's nice like that, he'll do the ones that take a little bit of effort. But we look at number 9, and we're asked to put it in factored form, find the real solutions and imaginary solutions, which means we need to factor it. So we look at this: 8x cubed plus 1 equals 0, and we're solving by factoring, right? That's the goal. Everything's already on one side equal to 0. We can move on. So now we factor. We look at that, is there a greatest common factor? 8x cubed and 1 have nothing in common, no greatest common factor. But every single time, start there. Now it becomes, oh, 8x cubed and 1, those are perfect cubes. So we can do our sum of cubes. Again, where we set this up. Ask yourself, what to the third power gives us 8x cubed? Well, 2 to the third power is 8. X to the third power is x cubed. What to the third power gives us 1? 1 to the third power gives us 1. Again, you can just do the cube root of those two terms to get those numbers. That, again, 2x and 1, gives us our first factor of a 2x, 1. The original is addition, so we go plus 1. Okay? Wow. Plus 1. There we go. To get that second parentheses, again, that's where we're going to write 2x cubed is 2x times 2x times 2x. 1 cubed is 1 times 1 times 1. Pair those up from left to right. That gives us our second parentheses. 2x times 2x is 4x squared. 2x times 1 is 2x. 1 times 1 is 1. To finish it off, we use SOAP. Same as the original is addition. Opposite from that would be subtraction. And this last one is always positive. That right there is your factored form. Right? 2x plus 1. 4x squared minus 2x plus 1. Okay, now to get the real solutions, what we're going to do here, or sorry, to get our real and imaginary solutions, we're solving by factoring. This is really equal to 0, so now we're just going to set each factor equal to 0, right? Solving by factoring. 2x plus 1 equals 0. 4x squared minus 2x plus 1 equals 0. Now this one on the left, subtract 1, divide by 2, x equals negative 1/2. That's a real solution, right? Negative 1/2 is a real thing. Even if you hate fractions, negative 1/2 is a thing. It's this second part. This is where we have to be careful because we do want to factor, right? We want to just be able to factor this because factoring and solving is a lot easier. But anytime we do this factoring using the sum or difference of cubes, this trinomial can't be factored, never. Which means if we can't factor it, we have to use the old quadratic formula, right? X equals negative b. Oh wait, let me move this, sorry. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Again, make sure you have that written down. You don't have to have that memorized. The biggest thing is you have to be careful when you're finding a, b, and c here, right? A is that leading term of 4, b is negative 2, c is 1 from these three coefficients. Biggest thing with a quadratic formula is you just have to make sure you're careful. So I'm going to set it up. Negative b, right? That'd be negative 2 plus or minus the square root of b squared. That's negative 2 squared minus 4 times a is 4 times c is 1. All of that over 2a, which is 2 times 4. Again, I like to work with this piece of the equation first, just to simplify it. So I'll do that right above. Negative 2 squared is positive 4, minus negative 4 times 4 is negative 16, times 1 is still negative 16. So that gives us 4 minus 16. 4 minus 16 is negative 12, and that's why it's going to have to be imaginary. We have a negative inside of our square root. I'm just going to rewrite what we have. X equals negative 2 becomes a positive 2. Plus or minus, this is the square root of negative 12 is what we just found. 2 times 4 is 8. And the last thing you have to do here is deal with this square root of negative 12. We have to simplify that as best as we can. Now the first thing you do is that negative, we can take it out, it becomes an I, right? That's how we deal with a negative. If there's a negative inside the square root, it comes out as an imaginary, hence imaginary solution. We also can deal with the 12, right? Break down the 12, see if there's any pairs. 4 times 3 is 12, 2 times 2 is 4, so we do have that pair of 2's, which will also come out as a 2. Right, so the 2 comes out, the I is out for the negative, and that single 3 stays inside. So the square root of negative 12 actually becomes becomes 2I root 3. Here, let me do it like this instead. The I comes out there, the pair of 2's comes out, and the 3 stays inside. So we can go one step further here. 2 plus or minus 2I root 3 all over 8. But wait, there's a little bit more we can do. 2, 2, and 8 can all be reduced by 2, so we have to, right? Leaving us with a 1 plus or minus 1I root 3 over 4. Do not try to reduce with what's inside the square root. We can't touch that, but we could reduce 2, 2, and 8 all by the same number, leaving us with 1 plus or minus 1I root 3 over 4. That would be our imaginary solution right there. I'm going to rewrite it up here. X equals 1 plus or minus 1I. We don't have to write the 1 with the I. Square root 3, all of that over 4. That is your process completed there. You have to be able to do all of that. Make sure you take your time on that quadratic formula bit. Alright, so here's number 10. This is the last one I'm going to do here. Again, we factor it, and then we're going to be able to solve. We're solving by factoring. Everything's on one side equal to 0. That part's done. Now, if we need to solve it, right? Factor this left-hand side. 64 and 27, you check, is there a greatest common factor? Again, there isn't, but we do know how to factor this. This is our sum or difference of cubes. So ask yourself these questions, right? What to the third power is 64? Well, that's 4. What to the third power is 27? 3 to the third power is 27. X to the third power is x cubed, giving us our two critical pieces there. Right, that first factor is 4 minus 3x. It's minus because the original subtraction. To get that second factor there, that's when we're going to write 4 3 times, 3x 3 times, and group them up. Okay. 4 times 4 is 16. 4 times 3x is 12x. 3x times 3x is 9x squared, giving us almost our completed factored form there. To finish it off, that's when we use SOAP, right? Same, opposite, always positive. Same as the original, which was subtraction. That's why that's minus. Opposite from that's addition. Always positive means that's addition. That right there is our factored form. 4 minus 3x, 16 plus 12x plus 9x squared. Okay, so now we're finding our solutions. Really, we're solving this by factoring. It's equal to 0. We set each factor equal to 0. So we're going to go 4 minus 3x equals 0. And 16 plus 12x plus 9x squared equals 0. We can solve this one on the left pretty easily. Subtract 4 divided by negative 3. X equals positive 4/3. That's your real solution. And this is where we have to play around with the whole quadratic formula. Again, we want to factor it, but we can't factor that trinomial ever when we do the difference or sum of cubes. Negative b plus or minus square root of b squared minus 4ac all over 2a. And the only thing here is you have to be careful. A is always attached to x squared, so a is positive 9. B is always attached to the x, so b is positive 12. C is that constant at the end, so c is 16. You have to be careful there when you're finding a, b, and c. Other than that, take your time and you'll be fine. X equals negative b, that's negative 12, plus or minus the square root of b squared, 12 squared, minus 4ac, 4 times a is 9, times c is 16, all of that over 2 times a, where a again is 9. And this has some, I guess, bigger numbers for you to deal with, so you might want to take out a calculator so you don't make any small mistakes here. Again, I'm going to work with that square root first. 12 squared is 144 minus negative 4 times 9. Negative 4 times 9 is 36. 36, right, this is 36. 36 times 16 is 576. So that's actually 144 minus 576. Again, we do that subtraction there, and we end up getting 432, which is a negative 432. Whew. Again, that negative inside is what's telling us it's going to be, and that's what's telling us it's going to be imaginary. So I'm just going to rewrite it. Negative 12 plus or minus, we just found out that becomes a square root of negative 432 all over 18. And now we have to deal with this square root. So I'm going to write it off here to the side. And there's quite a bit we can do here. Again, that negative, it's just going to come out as an imaginary I. Okay. We can break down 432. Now, what I can tell is we can divide it by a 3, right? That would be 104. Hold up. I'm sure we can divide it by a 3 because 4 plus 3 is 7, plus 2 is 9, and 9 we can divide by 3. Sorry, I had some sort of mental lapse there. 1 goes 1. What's happening? 144. Oh my gosh, I got it. 3 times 144 is 432. Again, you use a calculator here. Yeah, I should have used a calculator instead of just chucking it in my head. But why I chose that is because like 144 is really nice. 144 is 12 times 12, and that's all you need to do, right? We have that pair of 12s. That 12 comes out of our square root. That I is already sitting out in front of it, and what's left is that single 3 that we didn't use. Okay. So we can go one step further here. We're going to go negative 12 plus or minus 12i root 3. That's what negative 432 square rooted became, all over 18. And the last step that you have to do here is look at 12, 12, and 18. Do all 3 of those. Can we reduce all 3 of those by something? 2 definitely works, but can't we reduce all of these by 6, right? We can divide 6 out of all of them. So we have to go one step further, divide them all by 6, and that will leave us with what? Negative 2 plus or minus 2i root 3 all over 3. That is our imaginary solution. Negative 2 plus or minus 2i root 3 all over 3, which finishes off the problem there. Again, this problem takes a little bit of perseverance. You have to make sure you take your time and use a calculator, especially on this part right here. Don't be like me and try to think of it off the top of your head. Break it down as far as you can. I always try to find like a nice perfect square because that's easiest to pull out. But if you break it down into all 3s and 2s, eventually you will get to that same 12. Other than that, that finishes off all the questions I'm going to do for y'all. If you have any more questions, come to my office hours, send me an email so I can help you out that way.